Cool. So yeah, and just let me know at any time if like I sound weird or hail me if the seems like my screen's wrong or something too. But hello everybody inside the computer. Welcome to the tutorial. So I'm sharing my screen right now of a Google slide deck, so hopefully you can see that. And first off, just want to introduce myself a little bit. My name is Laura. And I am a software engineer at Prefect, focusing a lot on the developer advocacy side of things. So I'm contributing to our core engine, which is a lot of what I'm going to be showing you today. And then also trying to interact more with the community. We just had kind of like the pre-show talk about where tutorials go and where videos go. So that's totally my jam as well. So I'm really happy to be hanging out with you all today on the internet. To show you guys what it's all about. As a little backstory, I'm a previous Airflow user for 5 years. I actually gave a PyData DC talk where young Laura, aka old me, was pushing for Airflow. So you should look it up if you want. Also very funny at 2x speed, so I would recommend speeding it up. So yeah, so now I'm kind of split between Prefect Core maintenance and then doing the community management stuff as well. So I'll make a plug for it at the end too, but if you're interested in contributing to Prefect, they have a ton of open source stuff, which is what I'm going to be showing you today. And you can hang out with me more. So if you want to do that or want to hang out with the other contributors, then I'll give you some more tips on that later. But yeah, so that's me. And I already introduced him before, but this is Marvin, and he is the mascot of Prefect. And he's going to be here sitting right next to my computer, so I remember that I'm not alone in this room and that I am talking to people in the outside. Okay, so what I'm going to be doing today is walking through a basic ETL pipeline in Prefect. I'm going to build it from scratch. So like we're going to do every line of code together. And specifically, I'm going to be touching on the following Prefect features: schedules, state handlers, caching, and result handlers. And this will all become more clear later, but for people who've used Prefect before or jumped a little bit into it, maybe some of that is recognizable. And then I'm also going to be walking through orchestrating that flow with the open source server or the fully hosted Prefect Cloud products. So again, I'll talk in more depth about them later, but basically we also have 2 versions, an open source version and then a hosted version of our UI and orchestration layer. So I'll show you how to use your Prefect flows there as well. And I encourage you to follow along if you want. Some of my coworkers are in the Zoom chat. So if you ever get stuck installing something or running something, or you have a traceback or something, if you want to try throwing it there first, see if they can give you some help, then they'll be around. And but if you don't want to follow along, that's cool too. I'll just keep showing it. And then this is being recorded. And so if you want to follow along afterwards, you can, watch it then or show it to your grandchildren or whatever it is that you want to do with a video of a Prefect demo. And yeah, and I mentioned this a little bit earlier too, but it's kind of split into 2 parts. Part 1, you're just going to be, and I'll be demoing in just pure Python environment. I'm going to be using PyCharm to kind of like showcase everything, but you can do it anywhere you've got Python 3.6 or above. And then in part 2, the server stuff, if you're going to follow along, you're going to need Docker installed to run the commands that I'm going to show you. So yeah, just a heads up there if you don't have those installed now. So let's jump in. Basically, that's the little intro. So I'm going to escape out of here and take us to our PyCharm world we're going to be living in here for a while. And basically, the first point to bring up is that to use Prefect, you must install Prefect. And so you need to pip install it, conda install it, whatever it is that your package manager is. I'll actually just pull up really quick in the Prefect docs. There is this installing Prefect page. So kind of, stuff I said before, it requires Python 3.6. And then wherever you use your package managers, you can pip install it, conda install it from conda forge, pip install whatever you're into. There are a bunch of optional dependencies that you can install if you want. For this tutorial, you mostly don't need any of this. I kind of did it on purpose that we wouldn't need a bunch of other stuff. In practice, people usually have install with something, especially if they're using any cloud services to like run their flows. Usually, you know, if you're an AWS person or a Google person or whatever, you know, GCP person, then you're usually installing those extras. I am going to be sorry, showcasing a little bit of stuff with this Viz tool, but to use those visualizations, you also have to install this other thing called GraphViz. So don't worry too much about installing the extra, and I'll just like be briefly running the code up here for you to see what that does, but it's like a really minor part. So if you're having trouble installing that at all, then I wouldn't really worry about it. And yeah, regarding like, you know, the extras, basically on purpose, I'm trying to kind of shy away from that for the purpose of this tutorial, to keep it kind of lightweight and especially from an installation perspective. But again, in practice, usually people are installing extras related to their deployment location of choice. So that's the first part there. All right, so we have a blank screen. So let's do hello world first. I've got two little hello worlds just to like give us the very first taste of everything. So the basic hello world for Prefect is going to include a import of these two very important basic concepts for Prefect, this task and capital F flow. So we're going to use those two things. Task is a decorator. So we'll call it like this, @task, which can be used to decorate functions that maybe do some work, right? So classic hello world, not too hard to do, but just going to be printing out hello world. And this little unit here syntactically is how we're creating a single task. And then the other, you know, big idea for any workflow orchestration system and for Prefect as well is to create another container in which those tasks run. So we're going to do that with this type of syntax. My first flow for the exclamation point because we're so excited. Looks like this. So in this whole section here, we're using this flow import here as a context manager to instantiate a flow object as this name F. And then you'll see here that it looks as if we're calling this function and assigning it to this variable R. So really what's going on here is that we're describing what the flow is going to contain. So this function call here doesn't actually execute hello world yet, it just adds it to this flow called F. But if we actually want to run this flow, and in the simple terms we're in right now, that literally just means run this one function that we have attached to this flow. Then to actually do that, we call the run method of this flow. So again, this alias here in the context manager for this flow object. So this here is our most basic flow. And I'm going to copy that and come down here to my IPython console just to paste it in here and show you what the output looks like. So here I've just dropped everything in here. You'll see that a bunch of logging output shows up to give us some contextual information about what Prefect is doing for us. For example, beginning flow run by this name, you know, that matches with line 7. Starting flow run, task hello world, that's our task here. Starting task run, here you can see the work that we did, you know, for hello world is this print statement, and then some logging about how we finished this task run with the final state success, that our flow run is also typed success, and then this final output, it looks like this, which is a representation of the state object for this flow. So that's a little bit kind of like details, but the point of this right here is just to show you what this output kind of looks like. So, you know, something that I really like about this is that this feels very kind of natural to describe my tasks as these functions, kind of attach them to this flow with this context manager, and then run them after I've described how they work. So this is like, the super most basic, but this is only a single task. So let's do one more hello world before we get to our real demo, just to show you the next step up, which is also, why we want a flow in the first place is probably because we want to do more than just one thing. We want to do maybe 2 tasks, 3 tasks, 100 tasks, 1,000 tasks, who knows, and describe how they're dependent on each other. So, that's the main thing here for a workflow orchestration system. So let's get a new task in here so we can attach things together. So again, I'm going to use this task decorator, and I'm going to define a function. And in my little example, what I'm going to do is call it prefect say, and it's going to take a string and print it. And what I'm also going to do is have my hello world task not just print this hello world statement, but return some data. In this case, I'll have it return the string hello prefect, just to showcase this example. And then down here, I'm going to add to my flow that I also want the task prefect say to get called. And kind of the important thing that's going on here is that you'll see that the this variable r that is the result of this hello world is going to be passed as the argument to prefect say. So, but this is one task in the flow, this is another task in the flow, and this is a very natural, from a Python perspective, way to pass data down to the next function. And what this is going to do under the hood for prefect is actually establish a data dependency and a state dependency between these 2 tasks. That hello world has to run first because it has to produce R, because R needs to go into the prefect say task. So that's how this syntax just connects those together without any extra. That we do have another way you can specify these more explicitly, but this way, kind of a little bit more implicitly, and very natural to people who use Python functions, as I'm sure we all do. So if I just quickly go grab this, and I'm going to do this one more time down here, we'll see that I get a bit more output because now 2 tasks are running. My hello world task is running here, and my prefect say task is running here. And you can see that this first task does the work of printing out hello world, but my second task prints out this string that it got from the prior task, hello prefect. So that's just with easily adding this data dependency implicitly here with this functional type of syntax, we already get that they're related to each other. And to point that out even more, I'm going to call this method on a flow with f.visualize. This is the thing that Unique Graph is installed to run. So just heads up about that. And if I run that, then my visualization shows up on my other monitor. So I must drag it over here. And we can see a visualization of the nodes and edges in this flow. So it's telling us explicitly that hello world will produce S to be given to prefect say. So this is the relationship between the 2 of them. And again, from our perspective, we just wrote this nice context manager and to specify these 2 dependencies. So this is the total basics hello world of Prefect Core. And if nothing else, it's a convenient way to kind of organize how different code might be dependent on each other and call for a workflow graphs execution. This one's really simple, but you could even probably get some benefit just from writing some of your work the way you already do in functions and then describe their relationships as prefect tasks instead of as capstone scripts. But what we're going to do for the rest of this tutorial is kind of start with another basic ETL and then layer on some more features as we go. So you'll see that there's tons of more stuff than just this included in Prefect. And then, as I alluded to before, in the second half, we're then going to go into the orchestration layer and take a look at Prefect's UI and how we can extend, this local development experience and core only development experience, so to a situation where we have like a fully blown UI and state database that's also keeping track of all of our workflow stuff too. So that is the super basics here. So let me close this and I will delete this so we can get started on the next level here. Okay, so the next thing that I want to talk to you about is some general stuff about configuring Prefect. This is going to come up a little bit later too, but this is usually another kind of good first step. So Prefect, as we layer on more and more features, we'll find that some of them need to be configured in different ways. And configuration in Prefect can be done in a couple different ways, with environment variables, which is useful for temporary settings, or with the user configuration file. So I'm going to show you my user configuration file right now, which by default is in, let's see, my hidden directories here, is in your home directory .prefect config.toml. So if I open this, we can just take a quick browse at what this structure is. So toml is kind of like, you know, normal configuration type file with key values in here, some of which are organized into sections or subsections as well. So there's a ton of stuff to configure in here, especially everything under server isn't really going to be relevant, and cloud isn't going to be relevant until the second half of this tutorial. But there's some other things that you may be interested in. For example, the logging configuration, if you want to ever change what the base logging level is, or the log format. There's some stuff in here we'll be getting into about flow configuration. You can change how your tasks retries occur. We're not going to go super into depth about executors today, but you can describe other places that your flows can run, especially on a Dask cluster, which gives you a super high level of parallelism. Those are kind of the main points about config.toml at this point. So here is, you know, where we can change some of these settings permanently. And then again, if you want to do them by environment variable, they follow the naming convention of, oh, too many at once. Let's close this. They follow this naming convention starting with prefect _, then the name of the section, which would match the section name in your toml file, 2 underscores, the subsection, if there's a subsection, with 2 underscores, and then the key name, and then the value. So I think that's like pretty common format, but just heads up that that's how that works. Okay, so let's get into the demo itself. So I, again, from before I mentioned, I've focused on a pretty simple ETL that doesn't need any extra dependencies. Fundamentally to make this less about spending time in the task code and more time in the prefect code. So but I'm still gonna take a little time here to build it up from scratch. So the little situation that I made up is to use the consumer CFPB's consumer complaint database API to pull some data down from this REST API, do some super basic transformation on it, and then load it into a database. And again, to keep this super lightweight and easy, I chose a SQLite database. So those are kind of the 3 steps I'm going to put in here. And to kind of establish what this data looks like, so we get an idea of that, I'm going to jump over here in my Python console and just really quick, actually, I'll put it up here first, import requests, and then I will paste this over here just because it's really long, that we can make a call to request.get at this consumerfinance.gov API. I'm sending this params size 10, which is going to limit what my input is. There's a bunch of other stuff for this API to make different search queries, et cetera, as usual. But just doing this so we can see what this data looks like. And just for my convenience right now, we're still going to paste this down here so I can just interact with it quickly. Okay, so I have this R thing, right? R equals request.get. So this is my response object. And in this response object, there is this text, which is the response body from this GET request. So to kind of just get a chance to look at it a little bit, we're going to do a little JSON loads on it so that we can take a look at this as a Python dictionary. And, you know, I kind of like looked at it before, so I know what's interesting. But to highlight kind of the structure of this response, there's all of these keys at the top level. This is basically hitting an Elasticsearch endpoint. So this hits key is what we're really interested in. And in fact, if we take a look in there at what keys are in there, you'll see that we kind of have another layer to go in here to actually go see what the data that we got back is. So if I go one more level, this is a list of dictionaries of hits that came back. And I'm going to just pretty print one of them really quick so you can get a feel for it. So again, in my JSON response, there is a hits key, which itself has a hits key, and then I'll just grab the first of them just so we can kind of see. So this is what this data looks like. They have these ID, index, score, and then there's actually this underscore source key in here, which is where like the good stuff, I guess, is. So here's a complaint for General Motors Financial Company, Inc., apparently. And there seemed to be some problem with the vehicle loan of lease problems, right? So this is, you know, what this consumer complaint database is filled up with. And from a, you know, data engineering perspective, this is kind of the interesting data that we may want to get out of this response. And in my case, I just want to put, you know, a couple of these keys and values in my SQLite database so that we can kind of establish our basic ETL. So we're just going to hit this API, grab some data, you know, these first 10 just for our purposes, pick out a couple fields from the records we want, and then store them in this database. So all I've got here, though, is one call to request.get. So there's no prefect yet. So let's put a little skeleton around this ETL with the prefect stuff we learned from the hello world situation. So I will, whoops, go ahead and pull over again. The first things that we always want to get whenever we're writing prefect flows from prefect import task and flow, and then describe a task. I'll call it get complaint data, right? This is a function that gets the complaint data. And then, you know, this sort of like meat of getting this data, I'm going to put into this function and, you know, copy over some of this basic stuff that I did to turn this into a useful Python object. Looks like I also need to remember to import JSON up here and return that. So, and I'm even going to do some of this just kind of naively here, as this is kind of like the first level of what I want to get out of this. So while we're here, I'm also going to set up just some skeletons of those other two steps to peel out the keys I want from this structure per record, and then to actually store it in the database. So for that, peeling out the keys I want for this record, I'm going to call that parse complaint data. And again, totally just setting up a skeleton. So we'll put some more in here briefly, but I'm going to make that a task. And then I'm also going to make my database storage a task. I'll call it store complaints and spell that right. And then, you know, here we've got our super basic extract situation, you know, basic transform form situation. And then here we've got our basic load, right? So basic ETL. I almost clicked restart when my computer asked me if updates available, if I wanted to put those in. No. Okay. So down here, let's set up the second piece that goes in any flow, right? So we need to actually set up how these are related to each other, how these tasks are related to each other. So a flow object using this context manager starts with, takes, we instantiate this capital F flow object. Flows need names. So that's what this part is. We'll see those in the logs. And then later when we start to store them in our metadata database, we'll also use that there as well. And then this as F normal context manager stuff. And then here is where we're going to actually, you know, it will look like calling these functions, but it's really adding them to the flow and how they're related to each other by passing data amongst each other. So I know I want to call get complaint data, right? And I know that I want the data from that to get passed on to parse complaint data. So I'm going to, you know, pick a variable name here for what, you know, from a human readable semantic perspective, what I think is the result of this, which is kind of like the raw data. And then I know I want to call parse complaint data, which is the function I described above. And I want to give it the output from the prior task. So in that sense, it means, you know, on super basic case, it means I need to take this variable that was the result of line 24, pass it into 25. I also have broken my signature up here. So I also need to make sure that I put some space in here for this argument that I'm going to be passing in 25. And same idea with store complaints, right? We think that this is going to take the data from this transform step. So I'm going to want to, you know, layer in the same at the same type of thing that parse complaint data returns to this variable parsed, and then that's what I pass into store complaints. And then similarly, I need to make sure that my task signature is going to match up with it up here. So even though these two task functions up here don't really do anything, I am going to go ahead and drop this in here really quick and call f.visualize just to show you what this looks like when I call the visualization. Drag that over here. So, you know, super linear situation, but we can see the rendered visualization that we're going to get our complaint data first. The output of that is called raw, which will be passed into parse complaint data. The output of that is called parse and will be passed into store complaints. So got our E, T, and L all in a line. So that's nice. Okay, so let's fill in what these tasks actually do. And I will grab my code from the transform out of the oven where I cooked it during the commercial break, because that part is not necessarily that prefecty or interesting. So I'm just going to drop that in here. And I'm using named tuple, so I need to make sure I get a hold of that. Import named tuple. Okay, so oops, I doubled myself here. It was too perfectly cooked in the oven. There we go. Okay, so here I've just, you know, thrown in some like transform stuff here, where if I take in raw, which, you know, you and I know it looks like that list of dictionaries from the endpoint, then I can iterate through each of those rows, you know, change up where the data in their structure meets with my more flat structure, compose those into this big list of complaints that have been transformed, and then return that as my data. So, you know, there's other ways to do this for sure, but that's kind of like a super basic way. And we'll just roll with that for now. And then for the database storage one down here, we'll also go grab my stuff from the oven here. To keep this super simple, as I mentioned, we're going to use SQLite. And there's a couple things I need to import to for what I'm using. So I'm going to grab from context lib import closing and import SQLite 3. So these are two things I'm using in this super basic load task, which is going to create a SQLite database, or table rather, in a SQLite database that has this information. And then we'll use this insert command. And then here with our actual SQLite 3 connection to a file on disk called cfpb complaints.db, we're going to execute this create script on line 36. So that's going to make our table, and then execute many on this insert command with all the data from parsed. So again, super basic, but this is just going to squish everything into the SQLite database. So now that we have some stuff that actually does things here, we can, run this flow and see if it actually works. So up till now, I've been kind of copy pasting in this Python console, but a couple of times, especially as this gets bigger, I'm actually going to use PyCharm's run feature instead. So I'm going to, at the bottom of my flow code text here, actually put in f.run, there we go, which is the actual method that you would call to run this flow, like we saw with Hello World. So here in PyCharm, I have it configured to run this script when I press the big play button. So let's press play on that and see the output here. So some of the stuff that we set, like my ETL flow, is showing up here, beginning flow run. We see that it does this get complaint data task, then it does this parse complaint data task, the store complaint data task, and then sets the flow run as successful at the end. So we can do a quick, let's get to maybe a terminal over here, and see that again, my PyCharm is configured to be running these in this demos directory. So that's where my SQLite database was created. And we can go ahead and connect to the SQLite database here, check that we've got this complaint table, which is what I set up here in my script. And if I just collect a few things from complaint, see that we've got a bunch of stuff stuck in here. So in retrospect, this would probably be useful if I had provided a GitHub gist. So I'm going to do that immediately right now so that you all can get a hold of that, because this would be really annoying for you to write by copying from here. So I'm going to call this PyData Denver demo.py, paste this whole thing in here, just so you have, we're going to be layering more stuff on, but this, since I took so much stuff out of the oven for this one, I think it would be better if I provide this for you. So basic ETL flow, let's create that gist, and then I'm going to post it in the chat right now. If you guys check the Zoom group chat or find me on GitHub, you'll find that gist, so you can grab up to this part easily. Okay, so how do I close Zoom chat? There we go. So this is the super basic stuff here, right? And we can prove that this data goes into our SQLite database, and that's exciting. So let's get into layering on some more prefect stuff and see how cool prefect can do for us. And the first thing I want to show is the task library. So people who are coming from other workflow engines will also find this concept recognizable, that the workflow engine provides some sort of generic tasks that do work that people are used to. We have a task library over here that kind of interfaces with a bunch of different third-party APIs. There's stuff like shell tasks to just run some arbitrary stuff in your shell environment. There's some stuff in here to interact with like Google Cloud Storage or with Dropbox. So a ton of stuff in here. And what I'm going to do right now is take advantage of the fact that there's some stuff in here for SQLite and move some of the code that's in my custom database task and move it out into something in the task library instead. Specifically, I'm going to take this create script part, which is like smashed in with my loading data part, and move that into a separate task. And then, there's a theory generally, I guess, but Prefect definitely has kind of an idea that having really granular tasks is useful, especially because then you can turn them, sort of on and off as you want, configure them separately is, I guess, what I'm trying to say. You can get retry logic separately. So the smaller those units are, the more the Prefect engine can do work for you. Like test for retries, you know, alert on failure, etc. So that's definitely a, you know, a useful rule of thumb, I guess, depending on your use case, but in general, that's the idea. So I'm going to take this SQLite create script part and move it out into a different task. So I'm going to go ahead and script delete it. And I'm actually going to put this sort of at the top as sort of like, you know, kind of a little setup section from the perspective of me thinking about my workflow file. And I want to use the SQLiteScript task that's in the prefect task library. So I can import that like this: prefect tasks database SQLite import SQLiteScript, right? So, oops, it's from prefect tasks database SQLite import SQLiteScript. So any of that stuff you saw in the task library is available to install with your prefect installation, either a vanilla one like we have, which works with SQLite, or if you're using some third-party stuff, it may be separated into that optional dependencies setup. So it's up to you what you want to use for sure. And in this case, the SQLiteScript one comes totally for free in your vanilla prefect installation. So to instantiate a task from the task library, these tasks don't take this task decorator. They're actually task classes themselves. And this kind of like speaks a little bit to what this task decorator is actually doing. It is instantiating a task instance of the task class, capital T, task in prefect, that knows how to do this work in that task's run method. We can actually do kind of like a brief jump over into the source code even to take a look at what a task is over here, make it a little bit bigger. So this, you know, task class itself is what is being instantiated on your behalf when you use that task decorator and add a task to your flow. Or you can instantiate them yourself if you, for whatever reason, using the task library is a good reason, are actually working with task classes themselves instead of as functions. So if I jump over here, for example, I think I can easily jump into the source code for SQLiteScript. You can see it's a subclass of task. So we need to instantiate an instance of this task as opposed to use that task decorator because it's not a function. So it looks a little bit more like this, where we give it some sort of name, variable name, and then instantiate a instance of this task. So the two arguments that the SQLiteScript task can take is the database name and then the script itself. So my database name is cfpvcomplaints.db. And then the script is what I peeled out. Let's get rid of all my syntax breaking stuff. Peeled out of the task that was below. And then let's see, we've got our close parentheses here. So now it's as if create table is one of these sort of like function names from the perspective of when we actually add them to the flow. So that's kind of how you can think of it. But we got there by instantiating an instance of this class as opposed to annotating with a decorator a function of our own design. So if I jump down here, there's some other stuff I need to rip out of my SQLite or of my store complaints function, because I'm not going to do that work in this function anymore. And then I'm going to want to add it to my flow, right? So most basic way here, add it to the flow is like this. So again, this name create table, we can treat it as if it is like a function here. But I want to establish a relationship between the fact that store complaints can't happen until create table has already happened. And so, but they're not actually passing data to each other, right? It's just that create table has to have occurred and then store complaints can happen afterwards. So I'm going to use the imperative API, which is that I'm going to create a variable that describes you know, what the output or like final state of each of these populated table, there we go, each of these tasks are. So this DB table is a result of create table from sort of like my perspective, and populated table is the result of store complaints table. And then I can use these variables as task names to relate them to each other. I'm going to set upstream DB table. So to pull this apart, I'm saying that DB table needs to happen before populated table happens. And I didn't do this by passing data between them, as we saw the examples before with the functional API, as we call it, but instead by explicitly setting this dependency between the two of them using this set upstream method on populated table. So we call this the imperative API. And the major effect of this is that there is not a data dependency between these two anymore. The like node edge between them is not because they share data. It's just because one state depends on the other. So I'm actually gonna, pardon me, throw in f.visualize here when I run it instead of f.run. So we just get the picture. And there she is on my other monitor. Just so we can see that now I've created this arrow here that isn't annotated with any data because there's not actual data being passed between them, but that the SQLiteScript is an upstream dependency for this store complaints task. So some people write their entire flows in the imperative API and don't want to use the functional API. So you can mix and match them. You can use one over the other, whatever you're interested in. But where I guess it really shines, the functional API is really useful for describing data dependencies and state dependencies at the same time. And the imperative API is going to be more useful to describe the state dependencies with no data dependencies. So definitely, you know, they have their own strengths as well. All right, so here we've now got, you know, a little bit extra going on in terms of taking some of our work out into, so we don't have a big task, and also using the task library. So those are great. There's tons more stuff in the task library. Let's add another layer here, which what I've got on my list for next is schedules. So a common use case, especially for a batch ETL, you know, ours isn't written super great for this, but you could imagine like maybe we want to hit this API like once a day. In fact, the CFPB complaints database advertises that it updates daily, and get the latest information from it, and then just have our ETL running every day sometime that we pick, and put the newest stuff in. So to do that type of thing in Prefect, what we will do is create a schedule object and attach it to our flow. So those are kind of the two steps. And then we'll call that same flow.run, f.run in our case, and you'll see that it kind of just works after that. So let me go ahead and layer that in our example. I'm going to scroll up here because I now need to import some type of schedule. So from prefect.schedules. So we have a bunch of different types of schedules that you can use. And the one that I'm going to show is interval schedule, which is a schedule based on time intervals, right? So I already know that I'm going to also need date time to make this work. So I'll go ahead and import that up here because I'm actually going to create my schedule, you know, just conveniently by convention down here right before my flow, because the schedule is going to be attached to my flow. So to put this together, I create instantiated interval schedule instance, and I tell it what its interval is. And we're going to do 1 minute, which is the lowest you can really go with Prefect, and is way too fast for how quickly the CFPB database updates, but is going to be useful for our tutorial because we just have to get a little bit of popcorn to watch it as opposed to hang out for the next 24 hours. So I'm going to just set it up so that it works like this. And then this schedule object, we pass in to our flow at instantiation. So here is where I'm creating my flow object. It's another parameter that I can pass into my flow. So I'm just going to drop it right in here. And then change my line 62 back to f.run because I don't want to visualize this. I want it to run. And then grab your popcorn because now we're going to see what this output looks like, which will take at least 1 minute to enjoy. So here you can see that it tells us that it's got this ETL flow and it's waiting for the next scheduled run, which is going to be based on your time and then your interval. So here I've got my first run going, and then it tells me that my next run is scheduled for this time. Here, this one was at 56, and this one was at 57. So if we just wait a couple more seconds, then we'll be able to see that this flow will schedule itself for a minute later. So this is all just happening, in this one process. We didn't have to change our call to flow.run. It was our change in the flow instantiation that put it on a schedule. And you can imagine that these schedules can be, totally different, however you want. I'm going to pull up the docs as well about different types of schedules, because this is a basic one. Oh, there, our schedule popped. We all should have drank some champagne. Pull this over here just to point out, I'm using this super simple schedule with interval schedule, but there's actually a ton of extra stuff that you can specify on a schedule. You can use different types of clocks that take different types of input. Cron clock is very popular to do things by a cron string instead of by time delta. But you can also throw in a bunch of other nice stuff like filters to determine whether an event should be included or not. So you could filter things by like weekdays, or like if it should happen during business hours only, add some extra constraints besides what it may do. So like our every minute, maybe we only want to do it every minute from 9 to 5. And then adjustments to change, sorry, let's have a sip of water, to modify those events further. So these are all kind of like extra layer building blocks that you can put onto these schedules so that they could do even more specialized things for you. So I think, it's going down here a couple times. We've got up to 59. So let's give that over here. I'm going to press the stop button. And that's how we're going to stop otherwise this is just going to keep polling forever on time. It's in a while loop to determine when it should schedule the next run. Okay, so there's let's see my notes. I think three more things that I want to show you from a feature perspective just here in the Python world before I switch to us using Docker and the server. So let's take a look at that. So first up is I want to talk about caching. So we just ran the schedule, and every minute we ask CFPB's API, what's 10 things from you right now? And maybe CFPB would be mad at us if we did that every minute and would come after us, maybe, who knows? So one thing we could do instead is tell the prefect flow that it can cache data from that task by some other time interval and reuse it. So how this is going to work in in Prefect in our f.run is that the cache is going to be saved in memory in process for as long as this process is run. And so in this case, if I start up my schedules again after the first time, it will consider the cache to be set, and then later scheduled events for that same flow are not going to rerun that whatever task it is that I set to be cached. It's going to use the data that's already in memory. So again, I want to do this to get CFPB away from tracking me down. So I'm going to set this on my get complaint data function that it should be cached for some amount of time. So the way to set up caching in the most basic sense is actually as arguments that you give to this task decorator. So this is our first time configuring a task through its task decorator. We're going to open and close parentheses right after task. And there's a set of things, this is the first one we'll be talking about, that, oops, date time delta, that you can configure on a per task basis. So I'm saying for this get complaint data, cache the output of it for up to for 1 day, right? So if we all stay here and watch this schedule go for a whole day, then it will stop caching it after then and run this task again. But every other time, all these minutes between when I start this and a day later, it's going to use the return value from the first time it ran this task and not run it again. And to make this obvious to us too, I'm going to throw a little canary print statement into our code here. Requested this time. So we would expect the first time that this flow runs on this schedule that we see this print statement, but the other times that this flow runs on this schedule, then we would not expect to see this print statement. So I'm going to go ahead and press play so we can get it going. And then while that's happening, that movie's playing in the background, we can also just quickly take a jump into the Prefect docs just to showcase all these different things is what you could pass in through this task decorator or when you instantiate a task for any task. So this gives you a couple hints into a couple of the other features, some of which we aren't even going to talk about in this tutorial. But you can set a number of logistical things on your task, like its name or its slug, tags, which can be used. We'll talk about this a little bit for server and cloud, but to change how tasks are sort of like grouped, I guess, from the perspective of the orchestration layer. Stuff about retries for the specific task, the timeout for the specific task, the trigger for the specific task. Here's where cache for is. For example, cache for, cache validator, and cache key are all related to caching. So cache for is usually the first thing that people are using because this is what turns on caching and gives some time for how long it should be cached. Cache validator can be used to send some validation function or use some existing validation functions of further things besides the duration of what validates or invalidates a cache. And cache key is a way to specify a name for this cache, which makes it possible for this cache to be reused by other tasks, potentially tasks in other flows. So you can use this to make your cache live beyond just this specific configured task, but be useful elsewhere. So, our little use case doesn't have an example like that right now, but maybe you could imagine we run this get complaint data function in a couple different places, but we could use the same cache for a given day if it's already run in that day, even if it was in a different flow. Okay, our movie back here got to its climax of excitement, which is that here when my flow first ran, we see the output of this print statement, but you'll see that when my flow ran the second time, I don't see the output of that print statement. And if we look like a little bit closer here on the logs for get complaint data specifically, which is the one that we set cache for, you'll see that we don't see our print output, which gives us a hint that it didn't actually execute. And then we see that it finished its task run with final state cached. So this is also kind of a hint to us that the caching worked. And the effect is that now parse complaint data has the output from the very first time that this ran instead of the most recent time. So that's kind of like visibility about how caching actually gets run. Okay, so we're gonna do caching again a little bit more later when we get to server. But now I want to show you another thing in Prefect called state handlers, which is a way to specify some sort of arbitrary logic that you write that Prefect should do when a task goes from one state to another. You get to pick what state is interesting to you, like which state transition is interesting to you. Super common situation might be if a state of a task ever goes to fail. Do you want like something to happen, maybe ping you on Slack or like call your boss, I don't know, whatever you want it to do. It's whatever you want to write, but you could be watching in your state handler for any different type of state change. So you could be looking for this cache state change for some reason. You could be looking for success state change if you want to get you're the best ETL writer text every time that your ETL moves into a successful state. So anything that you want. So let's do a really simple example so you can see what the syntax is like and how it works. What I'm going to do is write a state handler that I will attach to all of these tasks that if they're failed, it will print out something to my terminal just so we can see it. But again, normally you're alerting somehow or doing any other type of special cleanup or code that you want. So I'm going to, at the top of this file, define this alert failed state handler. And state handlers always need to match the signature obj, which is going to be a task or a flow, old state, which is going to be the old state for that task or flow, whatever it is you're attaching the state handler to, and new state. So I'm calling them those variable names for convenience, but it needs to match the signature because Prefect Core code is going to be what actually calls the state handler for you. So you just set up like how you want it to custom react to these three things, and the pipeline is going to call this function and pass in these three things every time a state changes for every task and or flow that you configure to be running the state handler on state changes. So in my example, I want to print something out to the console here just to give us a little canary of what's going on. And in my case, I'm going to set it to print failed because I'm going to hide my little print statement canary here behind what is usually a very common type of statement to throw into a state handler, which is if new state dot is failed. So this new state object, this third positional argument, is the new state for whatever task we're in right now. And all states have a bunch of convenient is whatever type methods on them to check to see if they are of a certain state type. So is failed, of course, is like a very common one that people want to use in a state handler. I'm actually going to pull up another docs page here on state to show you that there's tons of states here, right, that things could go into. Usually the interesting ones from a state handler perspective, from a user perspective, might be running, failed, or these individual types of failed, success, if you want to do something special for success. Sometimes skipped to or retrying might also be interesting. So you can probably imagine, different situations where from a notification perspective, you might want to create a state handler that checks for any of those states. And just scrolling down here a little bit more, you can see that there's a whole series. Here's is cached, here's is failed is the one I'm using, is finished. There's a whole series of these convenience methods here that's going to check for different states for you. So you can probably use one of these to determine what you want to do, like what you want your logic to be hidden behind in terms of what state change you're watching out for. Okay, so this is just a floating around state handler function. I haven't attached it. I haven't configured any of my tasks to actually be setting the state handler. Just putting it in the file isn't good enough. We need to configure the state handlers for each of our tasks. So the way to do that is to pass that in as a argument here to basically the task init cards through the task decorator. So it's called state handlers, and it takes a iterable of state handler, callbacks that it should make. So we can go ahead and grab this and attach it to all of our tasks, right? So just for, an example, you could do this individually. You could have, bespoke ones for all of them. Maybe you have a general one that you apply to all of them. So what I'm doing here is I'm saying that the parse complaint data task should always check this state handler whenever it changes state. This get complaint data task should always check alert failed state handler whenever it changes state. And same thing here, this store complaints task should check alert failed state handler whenever it changes state. So you can have as many state handlers attached as you want. And to make this visible to us, I need to fail one of these tasks, right? Because otherwise we're not going to see our little canary. So I'm going to just throw raise exception in here, because Prefect will consider any uncaught exception in a task to be grounds to move a task into a failed state. So I can guarantee that new state.isFailed is going to happen for my transform task here. So also to make this a little quicker, I'm going to turn my schedule off. So I'm just going to sort of delete my schedule here so that we're just running instantaneously while I'm showing you these other features. I'm going to hit this play button. And you'll see that, you know, we've got some stuff here. My first task ran, my second task ran, my parse complaint data task tried to run. Of course, I raised this exception, and then you'll see that this failed print statement showed up. And then you'll see that I also tried to run my store complaints task, and again, I see failed. So what's going on here is that my first task failed because it raised an exception. And by default, my second task fails because its upstream task failed. It has a special type of failure called trigger failed, because its trigger is how we configure how they're related to each other. By default, the trigger is that everything upstream needs to have been successful. But trigger failed is a subclass of failed state. Is zooming going to be a useful situation for me? Not really for this picture, but you can see trigger failed here is a subclass of failed, is what this diagram is trying to get across. We can also go take a look in our code too, potentially. You can see this there. Let's get to trigger failed. Right, so here trigger failed is a subclass of the failed state. So as long as it's a subclass of whatever it is that you are checking against, your state handler is also going to execute against that. So up here, when we checked in our state handler is failed, we're also effectively checking for any subclasses of the failed state. So that's why we see it come out for both of these. Okay, one other point I want to make is that state handlers I alluded to a little bit before, but can also be attached to your flow. So your flow has a state too. We've been seeing, you know, flow runs report if they're failed or successful or what have you. So we can reuse the same state handler because the signature is the same. And when we instantiate our flow, that's where we would configure any state handlers that we want to attach to the flow. And then this state handler is going to be called against the flow state when it's when the flow changes state. So now, like if you kind of pre-look here, we don't see anything. We see a failed print statement for store complaints, and we see a failed print statement for parse complaint data. But if I give this another run, now that I've added that state handler to my flow, I'll see a third case here, which prints out after my flow changed to a failed state. So there are two different types of configuration, one for the flow, one for the task. And you know, it's up to your situation what you want your state handlers to be attached to, but you can use the same state handler you wrote for either case. They have the same syntax. Let's see, 8:14. One really quick side point about this is that I forced a failure state by raising an exception, taking advantage of the fact that uncaught exceptions in Prefect trigger a failed state. But we can actually do this like surgically for any type of state using something called prefect signals. So I'm going to go import from Prefect engine, import signals, because in signals, if I do a quick jump in here, there are a bunch of different classes of signals like fail signal, loop signal, trigger fail signal. These all match to states and is a way that you can force a task during its code to change into any of those states instantly. So here where I had put raise exception, instead I'm going to put in raise signals.fail. And this is it's not going to raise an uncaught exception anymore, but it is going to force my my task to be set into failed state instead. And I could also instead, for example, raise signals.success. This is going to change my transform my parse complaint data task to be successful before / without running any of this code at all. So just quick detour there about the fact that they're signals. You can personally change the state of your task. Maybe you want to put like a if statement of like try and do some work, and then or a try except statement yourself, and then raise a success state anyways if you have some really specific reason why you wouldn't want Prefect to fail something on a given exception. So you can kind of maybe imagine, you know, a couple different situations that's useful. Okay, so the last thing I want to show you before server is result handlers, which it's a little strange talking about because we're kind of changing how this is working in the next minor release in 0.11. We're on 0.10 series right now. But actually the user calls for this specific example is going to be kind of like mostly the same, so it's not too different. But it's just a little funny to be bringing up, but I'm going to show you anyways. So the whole idea of a result handler is to tell a task how and where to persist its output. And by default, it's whatever that return, whatever you returned. And then the result handler is going to know how you want it written down. So there's a bunch of different types of result handlers, which are mostly about different storage backends. So we have local result handler, which is the one I'm going to show you, which is about persisting the return value on the local file system. But there's ones for every cloud storage thing, right? Like GCS or S3 or Azure cloud storage. So those are all, you know, super popular too. And you could write your own, right? Sorry. So the local result handler is the one that we're going to use here. So I'm going to, you know, kind of quickly show you how that works. So all result handlers are in this location from prefect engine.result handlers. I'm importing local result handler. And this is, you know, again, just another thing that you can attach to your task at the task decorator. So it's with this result handler kwarg, and it takes an instance of this local result handler. So here I'm saying that get complaint data, you know, a lot's going on with get complaint data these days. But what I just told it is that your return value, you should write it down to file on the local file system. Local result handler by default is going to place your results in your prefect home directory, which is based on your config, in a /results folder. So I'm gonna just come over here really quick, get out of my SQLite from before. And if I change directory into my home directory /.prefect, we can see that there's this results folder. I can change the results folder. There's nothing in here right now because I cleaned it up before I came here tonight to Denver. And but now, whenever I run this flow, file is going to be put there that represents the data from this task's return value. So I think I got that all set up there. Oh, one more important piece. As of right now, to turn on this result handling, you also need to make a change in your config.toml down here where it says checkpointing, right? So checkpointing is kind of another term that we've been using thus far to refer to this result handler concept in the sense of that when they're called by the pipeline itself. So if we set this to true, instead, this configures our prefect installation to, at the end of any task, call the result handler and pass in whatever the return value was for that task. So easy configuration to miss, so I wanted to point that out. I almost missed it myself. All right, so if I give this a run, I'm going to also get rid of my raises so that we don't have any extra weird stuff, because we just want to showcase the result handlers now, and press play. You'll see that my code ran, And if I jump back over to my terminal, where before there was nothing in this results folder, now there's something, right? There's a file here instead. So I'm going to jump into a Python console, because by default, with all of the default result handlers, this file is a pickle, basically, of the return value. So we're going to need to deserialize it from using Cloud Pickle to actually kind of like see what it is. So let's do that over here. So I'm going to go ahead and open, actually, I'm going to do it from this terminal because it's convenient that I'm already in this results directory. So I'm going to open the file, which is called prefect result blah, 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 right? Yes, tab complete, there we go. And open it RB. Then I'm gonna read in the content of that file, and then I'm gonna import Cloud Pickle. So this is like Pickle, but more cloud friendly. And like you would expect with the Pickle library too, we can call load S on this content and see that this is that list of dictionary JSON objects, basically, that we got from the output of get complaint data is stored in that file. So it's just, now it's lying around on our local file system. You could use that to debug, take a look, whatever you want. And it's nice, you know, we have it persisted output on disk or in the cloud if you use like GCS handler or something else. Okay, the real shine for result handlers is best with Prefect Server. And this is a good time now to switch over to take a look at Prefect Server and talk about that. So let's get up my other terminal, because we're basically going to leave PyCharm land for a little bit, because we're gonna be looking at some other stuff. Okay. So over here, I'm going to do two things, two commands. These are the magical commands for starting up Prefect Server. First one is prefect backend, backend server. Let me make this a little bit bigger too, I think. Hopefully you all can see that. This is about the same size as the text over there. Okay, so prefect backend server is the first thing I'm going to run here. And I give this output backend switch to server. And then I'm going to run prefect server start. And prefect server start is a just easy API convenience to run a Docker Compose file that contains all of the services needed for Prefect's orchestration layer in Core. So we're seeing all the Docker output here of all the different services. And then somewhere in my bag o' tricks, I have not that one. I have this one. All right, so let's make a new one actually. If we now go to localhost 8080, port 8080, and press enter, we get to see the server UI. And this is, you know, pretty hot news. We only open source this UI like 2 or 3 weeks ago now. But it's been super great with the community, and a lot of people have taken a look at it. Maybe some people on the line have tried it out or saw some of our demos about it. So gonna rehash a little bit of that here if you've seen those demos before, but showcase a little bit of this, and then showcase some more of how caching and result handlers are useful to us now that we have server. So before I jump super into the demo, I do want to take a little architecture tangent to just kind of talk about how server is even structured, and like, you know, what we were doing up till now and what makes server different, and then even in the future, what makes cloud different. So this whole time we've been in some host OS, you know, I'm on Mac OS here. I'm running a Python process that has my flow code described in it, and I call flow.run in it. And that's what, you know, both describes my flow and actually runs my flow. And it either runs one time if it doesn't have a schedule, or if it has a schedule, this Python process just can stay open and keeps polling and keeps running my code on a schedule based on it determining what time it is and what my clocks were set. So another popular way to run like that is keep the same sort of orchestration thing going on in terms of it's a single Python process that you call flow.run, or you like leave it going for a long time and it's polling on a schedule, but you might have the actual work not be happening in the same process that schedule is being resolved, but with some distributed scheduler instead. And in the most basic case, these may still exist on the same host OS, though they don't necessarily have to. And over here, for people who don't know, this is the logo for Dask. So like Prefect is super interested, or I don't know, supporting people running their workflows on Dask. This is where you can get some great parallelism. So I'm sort of representing a Dask master node scheduler with lots of little Dask workers. So this is how you could get even a flow that's just running on, our flow running on a schedule in a Python process. As long as you can keep this process alive, you can keep these Dask workers and scheduler alive, whether they're on this host OS or somewhere else, then it can keep doing potentially a lot of work all at the same time on a schedule. Downsides, as you can probably guess from what I was saying, is this Python process has to stay alive, right? And then also we don't get a lot of introspection into like what's happening right now, except in the logs. So we can keep reading the stream of logs that's coming out, but eventually with a lot of flows that gets unmanageable. So nowadays, as of 3 weeks ago, you can instead run a version of Core's orchestration server with that command that I showed you, or there's some other ways that you can run it without using Docker instead. And but in our basic case, we're running a Docker compose file that contains a bunch of different services. The main thing that's going on here is that there's a GraphQL API layer, which is actually composed of GraphQL, this other service Hasura, and this other service Apollo, that kind of like combine together to be your entry point into this Postgres database, which is the database that's going to store what is actually scheduled, what is running, states of different things. So this information that gets stored in Postgres can survive past this Python process dying is the exciting part, right? Because we're persisting in a database. So that, as long as this Postgres database is still got its data and is accepting connections, or, like databases do, even if it goes down, wakes up and then can look at its same data, we can restart from the same situation that we were at before. There's, sorry, two other things going on in this Docker setup. Scheduler.py, which is the service that determines if stuff should be scheduled or not. So that's coming, natively for you whenever you do flow.run on a schedule in a single process, but it's actually a separate service when we package it up in this Docker container setup. And then a Vue.js based UI. So that's that pretty UI that we just were seeing before. So because we have all this data in this Postgres database, we can, about flows and their status, et cetera, we can render a UI that shows you what's going on. And so this is, the great benefit of using Core Server. But with more features comes a little bit more complexity, because now whenever we want to run a flow, it's not going to be as easy as f.run. There's going to be two steps. One is that we need to register the flow, which basically means that we need to send it through this GraphQL layer to be stored in Postgres, so that this whole database setup knows what it even is. So we'll register our flows. And then the other thing we need to do is start an agent, which itself is a Python process. We have a bunch of different types, but some sort of long running agent process, which is going to pull this Postgres database through this GraphQL layer to ask, should I be doing something? Should I be, is there a task I should be doing? Is there a flow that I should be doing right now? And when it does receive a yes to that question, it will go ahead and run. There's the most basic one, we're going to use this local agent, which means that this agent is both polling and doing the work itself. But again, you can get to a situation where you have distributed Dask clusters instead. The other nice thing to point out, some people may be like, well, now I still have another Python process I have to watch. What did I get out of it? Even if this agent goes down, as long as we can recover from our database situation, then we still have all of the information. So it's not as severe as our core only situation where we had to keep that Python process alive because we weren't persisting information about how the state of this flow in any other way. Okay. When it comes to cloud, there's a whole other world of making stuff more resilient and more distributed. And it's a little bit out of scope for this right now to super go into this architecture, but I just wanted to point out that these same two steps, register and an agent asking, should I do work, still exist in the world where you're using Prefect Cloud. You don't need to spin up Prefect Cloud in a situation. We're hosting it for you. So this is like a managed service. And you submit to our service the fact that you want to register a flow. And then you set up an agent on your infrastructure that is one of our Prefect agents that knows how to query Prefect Cloud. And then you can set up all sorts of special environments so that you can be running your actual task code in highly available distributed ways. But the kind of super important point for Prefect Cloud is that this cloud hosted part only knows how your flow wants to run in terms of what its dependencies are and what it needs to call next, what messages it needs to send to the agent, basically the minimal amount of information it needs to know to answer the question of the agent, what task am I supposed to run now? But it's the your infrastructure over here that actually knows how to run that task, knows the code of that task. And that does never get up to Prefect Cloud. It also never gets up to Prefect Server, except in the sense that they're kind of on the same computer, but that isn't actually in here either. So there's a ton of more information about kind of the philosophy behind the hybrid model, which is that we separate the code, actual code that you write, from the orchestration, minimal metadata orchestration information that we need to know to schedule them for you. So definitely look that up if you want some more information about that. Okay, so let's get back into setting up server really quick, just so I can show you how that works. Okay, so I have this flow, right? And now I have this UI running, which is also, just a representation of all these other backend services that are running. And I mentioned that there's two steps to running a flow with our orchestration layer. First, we have to register it. So you can see if I click over in this UI tab, there's a tab called flows, and there's nothing in here right now. And that's because we need to first register the flow. That's step one. So, conveniently, it's not that hard of a step. Let's change this to register instead, right? So all that's happening down here. So this register method is going to basically look at your config file, which we, with that prefect backend server command we ran right before we started the server, changes it to look at localhost GraphQL API. And then it's going to take this flow and register it at that core server instance. So if I press play now, you'll see that the output I get is totally different. I'm not running the flow, I'm not visualizing the flow, I am registering it to cloud, and it gives me, I'm registering it right now to Prefect Server because that's what I have it configured for. So you can see I get this output here, go to see this flow at this location, and and if you were looking closely, you also would have seen the UI update. Because now we have this my ETL flow, that's the name of our flow we've been working on in here. So I can click on this and take a look at details about this flow. But the fun part, I think, basically, that's really exciting about the UI is that we can run the flow from here. So instead of calling flow.run by code, we can press this button and we can configure details about this flow run in this nice UI instead of through the Python interpreter. So that's super great. Lots of people could do that, and it's a lot easier to keep track of, right? So I can press this run button. It will tell me that my flow has been successfully scheduled. this is what the UI looks like when it's scheduled something. It knows what task it's supposed to work on. It has this schematic that's the UI version of that flow.visualize here. We have a logs tab and a Gantt chart, but the other part that we're missing of this is that we need the agent in our architecture diagram. Let me pull that back up really quick, wherever I put it. We need this agent here to be polling, should I do some work? Should I do some work? Because this PyCharm process is no longer a long running process that's deciding if we're supposed to do this flow. We need this other agent to decide, should I be working on this flow? So conveniently, we have a one and done command here to start our agent called prefect agent start. This is going to start a local agent, which is a specific type of agent. We have other types. And you'll see, tons more output is going on. Things are happening in the UI, like all sorts of stuff is going on now because our agent now is able to pull the backend infrastructure, actually execute the work in the agent, and then report back to the database and thus to the UI that it has done all of this. So we can actually see, the logs conveniently here in the UI. We can even see, for example, let's see, our cached, state information. So this was our first time we ran this flow in cloud. So it says there's no existing cache because there are no past cache states found. But it does upload that data to our local result handler. So it puts that data into this file. This is just the log, right, of it. That's actually happening over here by the agent. And if we give this another go and press run again, so now I'm running offbeat aardvark, I guess. Here, this is another run of this flow. And I can come over here and see that for this task run, it actually found that there's past candidate cache states and is reading the result from that result handler instead. So a lot of the same sort of stuff that we were setting up in Prefect Core just in the Python process is also represented over here in Prefect Server, and similarly is existing in Prefect Cloud. Okay. So the last two things I think I want to talk about, I'm just looking at the time here, is to talk a little bit about, briefly about logging. So over here, our extract canary, right, for printing, we don't actually see that over here. And the TLDR is that if you want logs to show up in server or cloud, you need to use the logging, the official Python logging framework. That's what is actually getting received over here. So the way to transform our print statement here into a logging statement instead is to grab the logger instance, which the way to do that in a task like this is to access prefect.context.get the logger key. Let me import prefect up here so that we don't get the angry red lines. Okay, so we didn't talk about this a ton, but prefect.context is a dictionary of context that can be populated by you, but also is populated by the prefect infrastructure along the way with a bunch of useful stuff. Logger being super useful, but it also has a couple other things that both get used internally by prefect to track stuff, or may be useful to you in your task. For example, context has a key called yesterday or a key called today, which you can use to get the date easily inside your task if you just want to conveniently peel that off of context instead of derive it yourself. So we can, this logger variable here is now a logger instance, like a Python logging logger instance. So we can use, for example, logger.info or .warning, et cetera, anything normally from logger, and set that up. to use logging instead of print statements. So I also want to take this time to show you what happens when you re-register a flow. So as you are changing flows, especially if you're changing actual structure about them, because that needs to be communicated to server. But if I press play again to register this flow again, you'll see that under the flows, under flows here, you'll see that it's set to version 2. And if I actually click this toggle here, show archived, we can see that there was a prior version of this flow registered, and this is the new current version of this flow. So this is kind of another thing that can kind of get people tripped up, that every time we're registering, calling this register method on a flow to server and to cloud, new versions of that flow are being stored in the database so that it knows kind of like what the graph is and what it needs to do. So yeah, just calling that out, that's something you need to re-register when you change the structure of your flows, and that's what's actually being shown here in terms of archived flows and active flows. So if I click into here, now I could run another version. I could run this version 2 of this flow that I just submitted. And again, chatty back here as it's working on that. And over here, somewhere in here, let's see, looking for my log statement. Get complaint data. Where did it go? Right, am I missing it? My eyes can't work in this situation. Oh, well, I did, okay, so I guess this is two things happening at once, right? So I changed my logging statement to log, but this logging statement was always a canary for whether our caching was working, right? And then now I'm in a world where I have run this task before, and I have specified that this cache lasts for 1 day. So it's using my cache if you don't see my log. So that was a bad place to put it, but that's what's going on there. Okay, and that kind of segues well into the very last thing that I want to sort of touch on, which is when we're using an orchestration layer like Core Server or Cloud, this is where caching and result handlers like really get to shine, because when we're out here in Core only in process, the cache only exists in memory in this Python process. If it dies, it's gone. And then, that's bad, right? We don't super like that. But if we use Core Server, the reference to the result handler, where the result was actually persisted on disk or on in cloud, like in GCS or whatever for you, is saved in the database. So we could take a look. I think I can see it from the Gantt chart. Yeah, okay. So here's what the database knows. It knows that there's a result for get complaint data at /user/lora.prefect blah, 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 blah at this location, right? So this is the result handlers concept showing up for us in server. So the nice thing about this is that if our agent dies, if our agent dies and this cache doesn't exist in memory anymore, what will happen, since this result information is saved in the database, is that when this flow runs again, and let's say that this task is cached, your local agent will know from cloud that it can look for this file wherever it is. In this case, it's local to me, but a normal use case, I guess, would be that it's in Google Cloud Storage or S3, because then an agent anywhere in the world could get a hold of them instead of just the one on my host OS. But it will read the result from this location, and in that situation, you can restart from cache even if your agent went down. So this is sort of like where caching and result handlers really comes together. Again, I alluded to a little bit before, we are changing how it works a little bit coming up to kind of like merge these ideas a little bit more together. But that is the super big benefit of that. Okay, so I've talked a lot at you about all the things that I wanted to cover this time. You know, there's definitely more features that I skipped over. Maybe the most egregious that maybe I'll get yelled at later is I didn't talk about parameters, which is how to parameterize tasks or flow runs differently to provide more, I guess, like parameterization. I'm reusing the word, but parameterization at the flow and task level every time that you run it. So there's definitely some other stuff that I skipped. There's stuff about how to run conditional tasks, like conditional task trees. There's stuff about changing what is considered the reference task for when your flow succeeds. By default, it's the last one in the flow, but you could make it a different one if there's something else going on for you. So there's a ton of other features. And then I, didn't really talk about cloud at all, except that it exists. But if you want to use cloud instead of Prefect Server, like you want to use our hosted infrastructure instead, then you can, sign up for an account on cloud. There's a free tier available too. And then not only do you get all the stuff you get from Core Server, but there's some extra stuff in Prefect Cloud that does a bunch of performance optimizations. It provides an interface for you to store secrets securely with Vault that we host for you. There's this whole authentication thing. Sorry, I can make this kind of bigger. There's this whole authentication thing as well. You can have different teams that have different, access to stuff as well. So there's a bunch of good stuff going on there. So, maybe I'll give another stream or talk about all the good parts of cloud, but definitely check it out if you're interested. And in conclusion, now that you've hung out with me for almost 2 hours on your Wednesday night, thank you for hanging out and sticking around. Happy to answer some more questions. And then if you want to stay in contact, of course, you can find us on GitHub. We have a Slack that we hang out on all the time. We have a meetup page too. We're hosting a bunch of digital events, since digital is 2020. And in particular, this week was supposed to be PyCon, but it isn't anymore. And we're hosting some PyCon replacement events. So you should, if you're interested in hanging out, Friday we're doing open space and Monday we're doing sprints. We're replacing, we were going to do sprints at PyCon, and you could work for up to like 8 hours in a Zoom call with me if you wanted to on Monday. And then, as I mentioned at the very beginning, everything I showed you today basically is open source. So if you want to work on it or think it should be different, please become a contributor. Hang out in GitHub anytime, comment or open a PR. But we also have kind of like a sort of social situation in terms of we have a contributor Slack channel specifically in our Slack for us to talk to each other. And I host bi-weekly hangouts, which we call Contributor Cantina, where all the contributors kind of talk about what we're working on now or what we want to be working on. So it's a fun and growing group. So I would definitely recommend it if you were looking to get into open source or wanted a new open source project or what have you. So thanks again. And that's the show, and happy to chat more, but thanks so much for having me.